Let's have a look at these applied maxima and minima problems. So this is your question 3. Right, in question 3 you'll get an example with where you have to use Newton's method. Remember we had to work out the roots of an irrational equation, or basically irrational roots. So now here, these are similar to your grade 12. If you remember the last question in grade 12, application of differentiation. So certain examples are similar to grade 12 and certain examples, now you've learned new rules here, like the chain rule, product rule, which you can use to work out some of these examples. Right, so let's have a look at this one. The sum of two non-negative numbers is 30. The product of twice the one number and the square of the other number is to be a maximum. So you're looking for the key words. What are you going to be differentiating here? So you look for the words minimum or maximum. Okay, now that's with regards to calculus. Now to set up your equations, you look for the key words like sum, which means addition, difference, subtraction, product will be multiplication, and quotient will be division. So the sum of two non-negative numbers is 30. Let's identify these numbers. We do not know what the numbers are. Right. So let's the numbers be x and y. You can call them whatever you want to. A and B, P and Q. I'm calling these numbers x and y. So the first sentence then, the sum of two non-negative numbers is 30. So this non-negative, at the moment you cannot determine whether it's positive or negative. It's just a variable x and y. When we come to the end, if we have a positive and a negative answer, we will only consider the positive because we were told that it's non-negative. Right, so the sum of two non-negative numbers is 30. That means I can go x plus y is equal to 30. Simple addition. Then the product of twice the one number and the square of the other number is to be a maximum. Right, so the products here, this will mean multiplication. Twice means multiply by 2. Square, well, you know what square is. Square means raised to the power 2. Right, so let's call the product P. Right, it's a result of what's happening here. So now P is equal to, right, so the product of twice the one number, so let me go 2x, that's twice the one number, and the square of the other number is to be a maximum. So the other number, I called it y, so that's going to be times y squared. So now this has to be a maximum. Okay, so how will it be a maximum? We need to differentiate. Okay, we need to find the first derivative, and you know, at a maximum or a minimum, if you remember turning points, at the maximum or the minimum turning point, the first derivative is equal to 0. Right, so now, here I got P is equal to 2x times y squared. So I can go and make y the subject of the formula in equation 1 and then substitute into the second equation. Right, so if x plus y is equal to 30, so therefore I can go y is equal to 30 minus x, or x is equal to 30 minus y. It's up to you. So if I choose to do this, then I'm going to be replacing y with 30 minus x. So p is equal to 2x times y squared. And I'm replacing y with 30 minus x there. Okay, now we need to form a maximum. We need to find the maximum product. So I got p with respect to x. I can find dp over dx make it equal to 0. Now you have a choice now. If you were in grade 12, then you would be removing the brackets there. Right, you will have to square this and then remove the brackets, multiply out the whole thing. Right, so let me just do it first as if you were in grade 12, and then we will deal with it using our product, because this is a product and this is an exponent, so that means I can use the product rule combined with the chain rule here. We didn't learn that for nothing, right? We can use it here. Right, but the common way for the grade 12 will be just to square this. So that will be 2x. If I square this, 30 squared is 900. Right, then 2 times 30 times minus x, that will be minus 60x. And then minus x all squared, that will be a positive x squared. So here I'm removing brackets. You can just double check me. So now p is equal to 2x times 900, that will be 1800x, and then we got 2x times minus 60x, which will be plus 120 x squared, and then I got 2x times x squared, which will be plus 2 x to the power 3. So now I have it in a form of a cubic function, you can see that. So now we can find dp over dx. So our dp over dx, if I differentiate that, the derivative here will be just 1800. Oh, this one here was a minus, sorry, that will be a minus here, that's a mistake. So that will be minus 120 times 2, that will be 240x. And the derivative of 2x cubed 2 times 3, that will be 6x squared. Alright, so we found our first derivative. Right, so for a maximum product, what do? We make dp over dx equal to 0. Right, so you must write this down, dp over dx equals to 0 first, and now we can substitute into this equation. So if I substitute, what is my dp over dx? It is 1800 minus 240 x plus 6x squared, and that is equal to 0. So now what do we have here? We have a quadratic. This is a quadratic trinomial. So you need to solve for x. It's either you want to try and factorize, or you can complete the square, or you can use the quadratic formula here. Right, so you are not forced to go and factorize, because this is not a section on factorization. Right, this is a section on applied maxima and minima problems. So how you work this out is up to you. If you want to use the formula, you can use it straight. Right, so let me give you 2 minutes to factorize or use the formula. It's up to you. Right, so if you were trying to factorize this, then when you're trying to factorize a quadratic trinomial, check if it's possible to divide by the coefficient of x squared, and as long as you don't have any fractions here, see? So now if I divide here by 6 on both sides, let's see what happens. So here I will have x squared, and then this will be minus 40x, am I right? And this will be 300. Positive 300 is equal to 0. Right, so now we got a trinomial and this is a negative, that's a positive. So this, let's see if it can be factorized. Okay, although in the exam you're not going to waste your time and check for factors, and you just use the formula straight and you get your answer. I know this is negative positive, which will be negative negative x times x, which is x squared. Can this be factorized? Give me a calculator. So how do you check? You're dealing with large numbers, right? So how would you check if something can be factorized? If you wish to factorize it, you check b squared minus 4ac if it is a perfect square. If it's a perfect square, then it can be factorized. If it's not a perfect square I mean like 25. The square root of 25 is 5. Like 9. But 9 is a perfect square. Square root of 9 is 3. So let me do b squared minus 4ac. My b is minus 40. So that's b squared minus 4 times 1. That's a times c, which is 300. We get 400. The square root of 400 is 20. This can be factorized. Right. So what are the factors? Anybody found the factors here? This is a perfect square. So what did I get here? I got 400. Right, so we know the square root of 400 is 20. Right, so that's how you check if something can be factorized, whether you're dealing with large numbers or not. Right, so now what you have to do is, what are the factors of 300? Factors of 300, 30 and 10. 30 times 10 is 300. 30 plus 10 is 40. We are going to get, those are the factors. I'm just taking a guess. Okay, the easiest thing to think of is 30 times 10, and it does work. Right, so, but don't stress. Remember, you can use the quadratic formula. So now this will be minus 30 minus 10, because if you add minus 30 minus 10, you get minus 40. If you multiply negative times negative, you get a positive there. Alright, so now, what does that mean? So, it means that x is equal to 30 or x is equal to 10. Right, so now, there are two possibilities here. One when x is equal to 30 and the other one when x is equal to 10. Let's see now when we substitute back into this equation to solve for y. So what do we know? We know that y is equal to 30 minus x. So when x is equal to 30, y is equal to 30 minus 30, which is 0. And then when x is equal to 10, y is equal to 30 minus 10, which is 20. So basically what we have here is a combination. We got a combination of 30, 0 and 10, 20. So that's my xy, xy here. Can you see that? So let's call this x1, y1. Let's call this x2, y2. These are two different values here. But the question is, determine the sum of two non-negative numbers. They are both all positive here. So which one is correct? Now the product of twice the one number and the square of the other number is to be a maximum. Okay, is to be a maximum. So what is the product? The product is 2x times y squared. That is the product. So we want to check which one will give us a maximum product here. So let's do this combination here. When x is 30, y is 0. So I've got 2 times 30 times 0 squared. Do we need a calculator to work this one out? 0 squared is 0. 0 times anything? 0 there. Let's do the other combination. So you got 2xy squared. Now, when your x is 10, y is 20. What do we get here? 8,000, I think, am I right? Let's say 2 times 10 times 20 squared. Yeah, that's 8,000. Compare now. Which is maximum? Which is a maximum product? The answer of 0 or 8,000? Maximum means a very high value, right? The highest value here. So obviously 8,000 is a maximum value. So what does that mean now? What does that mean? It means that 30 and 0 are not applicable. Yeah, they do not satisfy this condition that we were given here. Right, so what does that mean? You go back now. Okay, so there's your maximum. You test out your solution. There's your maximum product here. So you go back, and then you can say, therefore, x must equal to 10 and y is equal to 20. So this, you go back, when x is equal to 30, x must not equal to 30. Can you see that? Or you can say x is equal to 30 is not applicable here. So x is equal to 30 is not applicable. It doesn't apply to what we want here. Can you see that? So x is equal to 30 is not applicable. X is equal to 10 is the value that we are using. So you can say, therefore, the numbers are 10 and 20. Right, so you're solving for x. Now you understand why this is not applicable. Check the question. Let's redo this part here. I'm going to work it out differently now. Alright, so let's redo this example using a different technique. Now, here obviously you have to set up your equation properly. You must understand the keywords sum, twice, square. You can see that twice means double something or 2 times. So what did we do? We got one equation in terms of the other. We manipulated this equation, y is equal to 30 minus x, and we substituted here. Now there is only one variable, which is x with respect to p. So what do we have here? Okay, we have your y is equal to f times g. I'm just calling it f times g. So this is the product rule. So the product rule, if I differentiate it, we know the formula is copy down the first, differentiate the second. So that's going to be f g prime plus g f prime. Write down the first, differentiate the second, plus write down the second, differentiate the first. So we know that. What else? What else? If I got y is equal to k times f of x to the power n. If we have a power, remember we use the chain rule. So if I differentiate this, y prime, that's going to be k times n f of x to the power n minus 1 times the derivative of f of x there, which is f prime x. So why am I showing you the chain rule? Because we have a power here, which is 2 there. So I'm going to be using the chain rule when I differentiate this. But when I look at the whole problem, it's multiplication. So now let's see what is the difference between working it out this way compared to the other way. Right, so what do I want? I want the first derivative, dp all over dx. So now what I'm doing is I'm treating f as 2x multiplied by g. G is 30 minus x all squared. Right, so the product rule is copy down the first, which is 2x, which is f, times g prime. So there's g. In order to differentiate that, I need to use the chain rule because I have an exponent, which is a number. You can see that. So the chain rule is multiply what's in front, 1 times 2, which is 2, and that's 30 minus x And 2 minus 1 is 1. So where am I now? Going k times n, f of x to the power n minus 1 times f prime x. So what is the derivative of 30? 0. The derivative of minus x is minus 1. So that is the chain rule to differentiate 30 minus x all squared. So that's f g prime now plus g. What is g? G is 30 minus x all squared times f prime. So what was f? F was 2x, so f prime, the derivative of 2x is 2. And that is, we're done with our differentiation. That is the product rule combined with the chain rule. So now what do we know? We know that for the maximum product, dp all over dx must equal to 0. Okay, so now let's see what we have here. Now, the first thing that you might want to do is remove brackets here. But that is not the quickest way to deal with it. If you're removing brackets now, it will take longer. It will be just as long as the previous one, even longer. So what do you notice now? We need to solve for x now. So you look for common factors here. Can you see common factors here? There's a plus sign separating. This is term 1 and this is term 2. Right, so this is factorization. So now, if I look at what's common here, I got 30 minus x here, 30 minus x there. Can you see that? What else do I have? I have 2 here, and I also have 2 there. So the highest common factor is 2 multiplied by 30 minus x. So I'm going to go 2 multiplied by 30 minus x. So I'm taking it out here. So what remains? If I remove this 2 times 30 minus x out, what remains is 2x multiplied by minus 1, which is going to equal to minus 2x. Are you clear with that? Plus, there's my plus here. And I took out 2 and I took out 30 minus x, but there's still another 30 minus x here. You're clear with that? So that's going to be plus 30 minus x, close bracket. Remember, this whole thing is equal to 0. Right, so now let's see what happens here. So I got 2 times 30 minus x, and I can simplify inside the brackets. So I've got minus 2x minus x, which is minus 3x plus 30 equals to 0. So now if I divide by 2 here, so that's just going to be 30 minus x, and that's going to be minus 3x plus 30 is equal to 0 divided by 2, which is just, I got rid of that constant there. So now I can equate 30 minus x is equal to 0, or minus 3x plus 30 is equal to 0. And we can solve for x now. So here, if I solve for x, so I know that 30 is equal to x, so that x is equal to 30. Here, minus 3x is equal to minus 30. So then x is equal to minus 30 divided by minus 3, which is equal to 10. So I've got, you can see, there's my 30, there's my 10. And now we know if I substitute 30, I'm going to get 30 minus 30, which is 0. We know, we just worked it out. Now 30 is not applicable here. If I substitute 10, so now remember this x is equal to 30 is not applicable here. X is equal to 10 is what we're going to be using, because 30 minus 10 is 20. We get a maximum product. So we got y is equal to 30 minus 10, which is equal to 20. And you know, you can write down, therefore the numbers are 10 and 20. So here we are using our N5 work on product rule and the chain rule.